This honors geometry lesson is on 2 more ways to prove triangles congruent. Chapter 3, Section 5. The objectives for today are to learn and apply the angle-angle side and hypotenuse leg or HL theorems to prove triangles congruent. The side-side-side, side-angle-side, and angle-side-angle postulates give us 3 methods of proving triangles congruent. In this section, we will discuss 2 other methods. The first method for today is Theorem 3.3, or the angle-angle side AAS theorem. This states if 2 angles and a non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So we are given that angle A is congruent to angle D, angle B is congruent to angle E, side AC is congruent to side DF, and those are marked in our diagram. What we know from the previous sections, we still could prove these triangles congruent without using angle-angle side. So what I want to do is I want to prove to you why angle-angle side theorem is an alternative way to prove triangles congruent. So based on what we know from previous sections, if we know that 2 triangles or 2 angles in one triangle are congruent to 2 angles in a second triangle, then those third angles are congruent as well. So I now know that angle C and angle F are going to be congruent. So if you look at the markings, we could now say that triangle ABC is congruent to triangle DEF based on angle-side-angle postulate. Or if you understand that if 2 angles and a non-included side of one triangle are congruent to the corresponding parts of another triangle, which means 2 angles and a non-included side, then you could go straight to the triangle ABC is congruent to triangle DEF based on the angle-angle side postulate. So these are just 2 different ways to prove these triangles congruent. So for the next example, we are still going to use the angle-angle side theorem, but I want to give you a strategy concerning overlapping triangles. So what you can see here is we have 2 triangles that overlap. We have triangle BFH and triangle BMR, and we're going to try to prove those congruent. My suggestion for this is to redraw the triangles as separate triangles that are not overlapping. So I'm going to go ahead and sketch over here triangle FBH, and then I'm also going to sketch the second triangle over here, which is triangle RBM. Sometimes separating the triangles allows you to easily decide if these triangles can be proven congruent and by what method. So we are given that BH is congruent to BR. We are also given that angle F is congruent to angle M. And we want to prove that triangle BFH is congruent to triangle BMR. So if you go back to the original diagram, what you're going to notice is that angle B is shared by both triangles. So using that reflexive property, I can mark that angle B is congruent to itself based on reflexive. And now you can see that I had 2 angles in one triangle and one non-included side that are now congruent to 2 angles in a second triangle, and its non-included side is congruent as well. So I can prove this triangle congruent using our angle side postulate. The last way to prove triangles congruent is using theorem 3.4, which is called the hypotenuse leg, or HL theorem for short. If the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and corresponding leg of another triangle, then the triangles are congruent. Let's quickly review the different parts of a right triangle. So in the diagram to the left, we have a right triangle marked. Remember that the side opposite the 90-degree angle will always be your hypotenuse, and the 2 smaller sides will always be your legs. So again, in order for hypotenuse leg theorem to work, a couple things have to be in play. We have to know that we have 2 right triangles. We have to know that the hypotenuses of both triangles are congruent, and that a corresponding leg of one triangle must be congruent to a corresponding leg of a second triangle. So if you look at the diagram on the right, we can see that both triangles are right, by the markings both hypotenuses are congruent and that one corresponding leg is congruent. The reason that the HL theorem works is if you use what you know from previous sections, we could actually mark that the segment that they share is congruent to itself based on reflexive. So as you can tell, hypotenuse leg theorem is somewhat of a spin-off of the side angle side postulate. Let's go ahead and look at one more example using the hypotenuse leg theorem. So for each example, I would like you to tell me which theorem can be used to prove each pair of triangles congruent, and if they cannot, go ahead and mark no congruence. So if you look at the first diagram, we do know that these are right triangles. So remember, in order for the hypotenuse leg theorem to work, we not only have to know it's a right triangle and that the hypotenuses are congruent, we must also know that the corresponding leg of one triangle is congruent to a corresponding leg of another. So what we're going to do is we are going to mark any other information that we can conclude. Now what we do know is that these are vertical angles, which means that they must be congruent. So even though this is a 90-degree triangle, we can't use HL theorem because we don't have a corresponding leg congruent to another corresponding leg, but what we do have is angle, angle, side. With the second example, we are also given that we have two right triangles. So remember what we know about the definition of supplementary, so that must be 90 as well. We are also given that the hypotenuse in each triangle is congruent. And then using that reflexive property, I can go ahead and mark that that segment, since it's shared by both triangles, must be congruent. So this is an example of our HL theorem. So we have two right triangles where the hypotenuses are congruent and they share a corresponding leg that is congruent as well. So let's quickly summarize the 5 different ways that we learn to prove triangles congruent. So in the first couple sections, we learned that triangles can be proven using your side, 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 your side angle side, or your angle side angle postulates. In this lesson, we learned that angle angle side, so if you have two angles and a non-included side, you can use angle angle side. And in right triangles, you can also use your HL theorem or your hypotenuse leg. So let's see how good we really are. For example 3, we're going to tell which method can be used to prove each pair of triangles congruent. So we can use any one of our 5 methods. So in the first diagram, we are given that we have two parallel lines, which means there must be a transversal. Based on this, I can tell that alternate interior angles are congruent, and I can do that marking. I can also state that vertical angles are congruent. So based on these markings, these triangles are congruent by angle side angle. In the second diagram, I want you to be very careful. So we did learn today that the angle angle side postulate is a way to prove triangles congruent. So we do have two angles in one triangle congruent to two angles in another triangle. Because I do not know anything about the sides, I can say that based on these markings, there is no congruence. In example C, we have two right triangles, so the first thing I'm going to try to do is to prove our hypotenuse leg. So what we are given is that we have two corresponding legs that are congruent. We're going to notice here that using the reflexive property, I can mark that the hypotenuses are congruent. So based on the HL theorem, I can prove that C, these triangles are congruent. For example D, I'm also going to look at my parallel lines. So if it helps, you can extend your line and extend your transversal. So based on corresponding angles, I can mark this angle congruent to this angle. I'm also given that a second corresponding angle is congruent and that one non-included side is congruent. So based on angle angle side, I can now prove these triangles congruent. In example E, I do have a right triangle, so remember in order to use the HL theorem, I not only have to prove that corresponding legs are congruent, I must also be able to prove that the hypotenuse is congruent. So based on this, I know I cannot use HL because I do not know if the hypotenuses are congruent, but what I do know is that I have a set of vertical angles right here. So based on these markings, I can say that in example E, these triangles are congruent by angle side angle. And lastly, I want you to look at this diagram here. So we have one side of one triangle congruent to another side in a second triangle, and we have a set of parallel lines, and we can see that the triangles share one side. So I'm going to go ahead and mark this as reflexive, and then I'm going to look at my parallel lines and the transversal to see what angles may be congruent using alternate interior angles. So here is my parallel line, and here's my second parallel line. So if I want to extend, and here's my transversal. Okay, so remember the alternate interior angles not only have to touch the same transversal, but they have to touch the line that's parallel. So I can mark that this angle is congruent to this angle based on alternate interior angles. And just to erase this so we have a better view, okay, so based on these markings, I do have two sides that are congruent to two sides in a second triangle, and I do have an angle. But what you're going to notice is that that angle is not included between the two sides marked congruent. So this is an example of the side-side angle postulate, if there was one, which there isn't. So we can say that based on this information, there is no congruence. In the next section, we are actually going to show you why the side-side angle method is not an appropriate way to prove triangles congruent. This is the end of the lesson. If you have any questions, feel free to watch the lesson again and take any notes. After watching the video for the second time, if you still have questions, please write down your questions and then see me in the next class.